No, sir.
That means you are writing in a book, no? Isn't it?
Yes, sir. Yes.
Okay, okay. Then write the topic. Errors in vernier instrument. Errors in vernier instrument. Errors in vernier instrument. You had sent me the homework, no? I can remember. Okay. Finish writing.
Yes, sir.
Okay. Then there is a simple method to find whether there is a error or not. Okay. That method is this is the vernier scale, this is the main scale. No? So the main scale 0, that means this is the main scale 0. Right? This is the main scale 0. This is the vernier scale 0 line. Okay. If these two lines are not coincide with each other, that means that instrument has an error. Got it? If these lines are not coinciding with each other, that means that instrument has a error. Understood?
Yes, sir. Understood.
Sure. Okay, I'm here. Ah, zero is not in there. Ah, this is good. In this one, this is the main scale 0 line, and this is the vernier scale 0 line. When the jaws are touch with each other, okay, when the jaws are close or touch with each other, if these two lines, that means vernier 0 line and the main scale 0 line is not coinciding with each other, that means there is an error. Understood?
Yes, sir.
Okay, then write that one. Right? When the when the when the jaws are closed, when the jaws are closed, when the jaws are closed, dash, when the jaws are closed, dash, jaws are touching with each other, when the jaws are closed, dash, touching with each other, touching with each other, touching with each other, touching with each other, vernier scale 0 and vernier scale 0 and vernier scale 0 and main scale 0 lines are vernier scale 0 and main scale 0 lines are not coinciding properly, not coinciding properly, not coinciding properly, there is an error. Not coinciding properly, there is an error. There is an error. There is an error. Finish writing.
Yes, sir.
Next point. Next point. There are two types of errors. There are two types of errors. There are two types of errors. There are two types of errors.
Okay, sir.
Okay. That means there are two kind of errors. First one is negative zero error. Second one is positive zero error. Negative zero error and the positive zero error. Negative zero errors is occur when the vernier scale zero, okay, vernier scale zero place in the left side of the main scale zero. Look at this one. Vernier scale zero is in here and main scale zero is in here. That means the vernier scale zero is placed to the left side of the main scale zero. Understood?
Yes, sir. Understood.
Then positive zero error. In the positive zero error, vernier scale zero is placed in the right side to the main scale zero. If it is positioned in the left side, that means that is negative. If it is positioned in the right side, that means that is positive. Understood?
Yes, sir. Understood.
In signal we called this is placed in the Dakuna side, that means Dana. Dakuna nam Dana. Right mean positive. Then automatically left become negative. Understood? You can remember in that way. That is the easiest way. Right side positive, left side negative. Understood?
Yes, sir. Understood.
Okay. Then let's write positive error as the first one. Put the number 1 and write positive zero error. Positive zero error. Positive zero error. Positive zero error. Under that write. Under that write. If the vernier scale zero is positioned, if the vernier scale zero is positioned, if the vernier scale zero is positioned, if the vernier scale zero is positioned to the right side of the main scale zero, to the right side of the main scale zero, to the right side of the main scale zero, that is called as a positive zero error. That is called as a positive zero error. That is called as a positive zero error. Finished?
Yes, sir.
Okay. Then this is a positive zero error, so you have to subtract the error. Understood? You have to subtract the error. That means you are reading something beyond. That means you are reading something greater than the actual value. Understood? Your reading is greater than the actual value.
Okay, sir.
As an example, think like this. As an example, uh, you want to measure this line. You want to measure this line, but you are starting with 0.5 millimeter, 0.5 millimeter, and here the N1 is 5.5 millimeter, 5.5 millimeter. So you haven't started with zero, no? So what you have to do to get the actual value? What is the actual length between this line? Did you get my point? This is not started. Okay, wait. I will write in a simpler way. This is 2 centimeter and this end is 10 centimeter. Okay. Then, then what is the length in between this? What is the length of this line?
10 centimeters.
Sorry,
10 centimeters?
not 10 centimeter. You have started with 2.
5 centimeters.
Here 2 and here 10, no? I'm
Sir,
asking.
I didn't understand.
Okay. Think like this. You have a line. Okay. You have a line. Then you are going to measure this line by a ruler. To measure this line by a ruler. Here, this point is 2 centimeter in the ruler and this point is 10 centimeter in the ruler. So I'm asking the length in between these 2 points. What is the actual length between these 2 points? What is the length? You have to
Sir, is it 10
sorry?
8 centimeters?
That is 8 centimeter. It is 8 centimeter. It is 8 centimeter. Actual, this is in the ruler. In the ruler, you can see this line is coincide with 10 centimeter, but the actual value is 8. The reason is you have started with 2 centimeter. You have started to measuring with 2 centimeter, no? Then this point is 10 centimeter. So what you have to do? You have to subtract this one from here. That's how
10
you can
from
get,
2.
yeah, you have to subtract 10 from 2 and then you can get the 8 centimeter, the actual reading. Here also, like that one. You are starting with a greater value and end with a greater value. That means more than actual value. So what you have to do? You have to find the error and you have to subtract it. You have to subtract it. Understood?
Yes, sir. Understood.
Okay. Uh, can you draw this one quickly? Okay.
Okay, sir.
Quickly. Finish drawing? We're still drawing.
Still drawing, sir. Done, sir.
Okay. Then let's see how we can calculate the error. Here, error is equal error is equal least count into uh, coinciding part number. Coinciding part number. Right? Coinciding vernier part number. Vernier part number. Coinciding vernier part number. Okay. Write this up. I will explain.
Okay, sir.
Okay. I will take this as as the example. Here, when you are getting the error, only So you have to only observe the vernier scale. Okay. Here, the vernier scale, that means this line is coinciding with the main scale, no? Understood? Can you see? This line is directly coinciding with the main scale. So this is the vernier part number we are looking for. That means this is 0, this is 1, 2, 3, 4, 5. So fifth one is coinciding with the main scale. Understood? Yes or no? You do understand?
Yes, sir, understood.
Okay. Then you can write error is equal least count into coinciding vernier part number. Coinciding vernier part number. Here least count is 0.1 millimeter. Actually it should be given, but I assume that it is 0.1 millimeter. Then coinciding vernier part number, that is 5. That is 5. That is 5. Then you have to multiply this 5 by 0.1 millimeter. Then the answer is 0.1 millimeter. This is the error. Understood? This is the error. Then what you
Yes,
have
sir,
to do
understood.
is you can take the reading from this vernier instrument and you have to subtract the final reading by this error. So you can get the actual value. Understood?
Yes, sir.
Then I will write actual value equal reading minus error. Actual value equal reading minus error. Reading minus error. Okay, then I think no, just put example. I think you draw this one, no? You have already draw this one, no? In your diagram, is the fifth one is coinciding with the main scale? Or you just draw that one?
Sir, should we draw and write this one also? Or only
Mm,
write this?
no, you have drawn the figure, no? In your figure, the fifth part number is coinciding with the main scale.
Uh, yes, sir, but not exactly in the figure, like in the figure.
Okay,
So,
I think better to draw this one again, no?
yeah, sir.
No
Okay,
need to
I'll
draw
draw.
everything. No need to draw everything. Just this part. Just this part. And find the error. And write this one. Actual value is equal reading minus error.
Okay, sir.
Finish.
Not yet, sir. Done, sir.
Okay. Then write the next subtopic causes for positive zero error. Causes for positive zero error. Causes for positive zero error. Okay, the major reason is oxiding or oxidizing the this jaw part, oxidizing. When oxidization happens, when oxidization happen, a small layer is built in here. A small layer is built in here and act as a barrier to touch these jaws with each other. Understood? Then, then what happened? Automatically, this vernier scale is placed in the right side of the main scale zero. Understood? That is the very first reason. Understood or not?
Understood, sir.
Okay. If something is placed, that means there can be some dirty particles or some dust particle, or if these are rusted, okay, these are rusted, that means again there is a barrier is built. Understood? Again there is a barrier is built. So those are the major reasons for positive zero error. Those are the major reasons for positive zero error. Okay. Write the first one. Write the first one. These jaws are, these jaws are, these jaws are metal particles, and these jaws are metal, not particle, these jaws are metals, these jaws are metals, and oxidization can happen on, oxidization can happen on these jaws, these jaws, these jaws, building a small layer, these jaws, by building a small layer, by building a small layer. Write the second one. dust particles and dust particles and dust particles and dirty particles, dust particles and dirty particles, dirty particles, dirty particles can be placed in this can be placed in its jaws, can be placed in this jaws, can be placed in this jaws, causing a barrier, causing a barrier, causing a barrier, causing a barrier. Okay. Third one, third one, third one. Rusting can be happened on. Rusting can be happened on. Rusting can be happened on jaw surfaces. Rusting can be happened on jaw surfaces. Jaw surfaces causing a small layer. Causing a small layer. Causing a small layer. Finish.
Yes, sir.
Okay. Then that's all about the positive zero error. Let's do some calculation later. Write the next topic. Negative zero error. Negative zero error. Negative zero error.